Hello students, I am your Rasayan Guru Dr. Chandramouli Sharma. In this video, we'll discuss of questions and numericals based on the colligative property and vent-Hoff factor. In this video, we'll discuss exercise question number 31, 32, 33, 40 and 41. As we all know that there are four colligative properties. First one is the relative lowering in vapor pressure. Second one is the elevation in boiling point. Third one is the depression in freezing point. And fourth one is the osmotic pressure. Relative lowering in vapor pressure we have already discussed in previous videos. In this video we'll discuss about the numerical and questions based on these three colligative property. The formula of these colligative property are just given on your screen. First colligative property is the elevation in boiling point. Second one is the depression in freezing point. And third one is the osmotic pressure. And also in this video we'll discuss about the numericals based on the vant-Hoff factor and correlated numericals with colligative property. For that I have mentioned the two formula which will be used in these questions. Fourth one is the degree of dissociation, that is alpha, and fifth one is the degree of association. For the solution of these questions, let's move to our class. Welcome to class students. Question number 31 is just given on your screen. In this question, we want to compare depression in freezing point of different three organic molecules. First one is the acetic acid, second one is the trichloroacetic acid, and third one is the trifluoroacetic acid. Among these three, which will have the maximum depression in freezing point and which will have the minimum depression in freezing point? For that, just discussed about its property. As we all know that among the hydrogen, chlorine and fluorine, hydrogen will have the least electronegativity and fluorine will have the highest electronegativity. And due to the highest electronegativity of fluorine, it produces ions quickly. While in the case of the hydrogen, it does not produce ion as quickly as fluorine and chlorine. So, in trifluoroacetic acid, more ionization will be there. And due to this, its depression in freezing point will be highest. So, the correct order of the depression in freezing point is acetic acid, then trichloroacetic acid, then trifluoroacetic acid. Next question is 32. In this numerical, we want to calculate depression in freezing point of the solution. First one, what they have given? They have given the weight of solute 10 gram, then weight of solvent, that is 250 gram, then Kf, Kb, and molecular weight of the acid you can calculate by putting the value of atomic mass of each and every elements, and it will be 122.5 gram per mole. Which equation will be useful for this numerical? That equation is given on your screen. Delta Tf is equal to Kf multiplied by small m multiplied by I. Small m you can easily calculate by this formula, W multiplied by 1000 divided by molecular weight multiplied by weight of solvent. Put all the values, and all the values they have given in numerical. By multiplication and division, you will get its value 0.33. So here we have value of molality and Kf, and we want to calculate delta Tf, but still we don't have the value of I. I can be calculated by this equation. Alpha is equal to I minus 1 divided by n minus 1. For that, we should have the value of N and we should have the value of alpha. And we can take 2 because when acid is ionized, then its value will be 2 because it will produce 2 ions. First one is the H plus and second one is its acetate ion. So you can take it as a 2. But we don't have the value of alpha as well as I. So first we'll have to calculate alpha. Alpha can be calculated by this equation. Alpha is equal to under root Ka divided by C0. This equation you have already studied in 11th standard in ionic equilibrium. Ka is equal to dissociation constant of acid and C0 is equal to molarity. But here the value of molarity and molality will be same because water is taken as a solvent. So put the value of Ka and put the value of C0, you will get the value of alpha is equal to 0.065. Now put the value of alpha in the formula of degree of dissociation, you will get the value of I is equal to 1.065. Put the value of alpha in equation number 1, that is delta TF is equal to Kf multiplied by small m multiplied by I. After putting all the values, when you multiply by each and every value with each other, then you will get its value 0.653 Kelvin. So final answer is depression in the freezing point of the solution is 0.653 Kelvin. Question number 33. This is the most important numerical of this chapter. In this numerical, we want to calculate Vance-Off factor I and Ka for given acid. For that, what they have given? They have given the weight of solute, that is acid, that is 19.5, weight of solvent, that is 500 gram, and molecular mass of the solute that you can calculate by putting all the values of atomic mass of each and every element. Then it will be 78 gram per mole, and Kf, that is 1.86. First, we want to calculate the value of I. By using which formula you will calculate its value? The formula is just given on your screen. Delta TF is equal to Kf multiplied by small m multiplied by I. For that, we should have the value of molality. For that, use the formula of molality. Molality is equal to weight multiplied by 1000 divided by molecular weight multiplied by weight of solute. Put all the values. After multiplication and division, you will get its value, that is 0.5. That is very easy to calculate. Now next step is the most important step for finding out the value of I. Put the value of molality in equation number 1 and by multiplication and division, you will get the value of I, that is 1.075. The whole calculation you can see on the screen. Next step is we want to calculate the value of Ka. But question is how to calculate value of Ka. That can be calculated by the formula of alpha. Alpha is equal to under root Ka divided by C0. That equation you have already studied in 11th standard in chapter Ionic Equilibrium. But for that, we should have the value of alpha and C0. Now we have calculated the value of molality. So that will be the value of C0 because water is taken as a solvent. So there is no problem for that. So whatever the value of molality, that will be the value of molarity. So that problem is resolved. So C0 will be 0.5. But we want to calculate alpha. So alpha can be calculated by the formula. Alpha is equal to I minus 1 divided by N minus 1. Here the value of N is equal to 2 because when acid is ionized, then it will produce one positive ion and one negative ion. In that way, N is equal to 2. We have already calculated the value of I, that is 1.075. Put all the values and after the calculation, you will get the value of alpha, that is 0.075. Now from that value and C0, we want to calculate the value of Ka. So alpha is equal to under root Ka divided by C0. So alpha square is equal to Ka divided by C0. So Ka is equal to alpha square into C0. So put the value of alpha, C0, by multiplying, you will get the value of Ka, that is 2.81 into 10 raised to minus 3. So in this numerical, the value of Vent's factor I is equal to 1.075 and Ka is equal to 2.81 into 10 raised to minus 3. Question number 40. This is very easy sum. In this sum, we want to calculate the amount of calcium chloride. For that, what they have given? They have given the weight of the solvent, that is 2.5 liter. Molecular mass of the solute that you can calculate by your own, and it will be 111 gram per mole. Then temperature is given 27 degrees Celsius, so it will be 300 Kelvin, and pi is equal to 0.75 atm. So these value they have given, and from that value we want to calculate the weight of solute. So use the formula of osmotic pressure pi. Pi is equal to WRT divided by MV multiplied by I. They have given the value, it is 2.47. So make the subject of W. So W is equal to pi multiplied by capital M multiplied by capital V divided by R multiplied by T multiplied by I. Put all the values, but one thing you should remember, that take the value of R is equal to 0.083. By multiplying and dividing all the values with each other, you will get the value of W, that is 3.38 gram. The calculation you can see on the screen. So the final answer is the amount of calcium chloride will be 3.38 gram per mole. Question number 41. In this numerical, we want to calculate the osmotic pressure pi. First of all, what they have given? So they have given weight of the solute, that is 25 milligram. So 25 milligram is converted into gram by multiplying 10 raised to minus 3. Then volume of solvent is equal to 2 liter, and molecular mass of the solute that you can calculate by your own. Solute is given K2SO4. Put the value of atomic mass of each and every element. After that, you will get its value 174 gram per mole. Temperature is given, that is 25 degrees Celsius, and by adding 273 you will get its value 298 Kelvin. In this numerical, they have given K2SO4 is completely ionized. On ionization, it will produce 2K plus 1 SO4 minus 2. So total number of ion will be 3. So its value will be 3 for Vent's factor I, because it produces 3 ion. Now use the formula of osmotic pressure pi. Pi is equal to WRT divided by MV multiplied by I. Put all the values of W, R, T, M, V and I, and by multiplying and dividing all the values, you will get the value of pi, that is 5.33 into 10 raised to minus 3 atm.